Hi, today I'm going to introduce you a new technology from a thesis that I recently read from the internet. The title is called Current Control of PMSG using Interval Type 2 TS fuzzy systems. PMSG, which is the abbreviation of Permanent Magnetic Synchronous Generator, and this generator is commonly used for converting energy or improvement on electric vehicles. And there are different types of permanent magnetic synchronous motors or generators. The difference are the magnet embedded type. The most common types are surface mounted type and interior type. The interior type is widely used in electric vehicles such as Tesla due to its high torque characteristic, while the surface mounted one has lower reluctance torque. The term of permanent in the word permanent magnetic synchronous generator means a generator where the excitation field is provided by a permanent magnet instead of a coil winding. And the term synchronous refers to the rotor rotates at the same speed of the magnetic field. In this paper, the researcher obtained the IT2TS fuzzy model on the PMSG, and the fuzzy controller is based on the concept of parallel distributed compensation. Next, this system can obtain the Lyapunov theorem to analyze the stability. In short, Lyapunov theorem is a method that scientists widely use in discussing the stability of differential equation or differential equation which describes dynamic systems. In this experiment, the AC power from the permanent magnetic synchronous generator will be converted into DC via a three-phase 4-bridge rectifier, which is quite commonly used in rectifying alternating currents into direct current. But this one is controlled by 6 semiconductor switches as shown in the figure. And also this 6-switch 4-bridge rectifier is controlled by the main topic of this article, which is the IT2TS fuzzy controller. According to the figure, we can see the three-phase winding currents are fed into an analog to digital converter, and then the ABC frame of the currents was transferred into DQ frame. The DQ currents are fed into IT2TS fuzzy controller, then outputs two signals of DQ voltages. Next, the duty ratio of 6 transistor switches are calculated by the algorithm of space vector PWM, as known as pulse width modulation, to vary the speed of alternating current from DC power. These procedures are all done by utilizing the Renesas RX62T microcontroller. Next, we are going to see the part of designing of the TS fuzzy current controller. There are some really complicated functions that are obtained in this section. Let's just see the formulas provided in this paper. In the IT2TS fuzzy control systems, there are upper membership function and lower membership function, which represents the model oscillation of a nonlinear system. AP, BP, CP, and DP are the boundaries of the membership function as shown in the below figure. And we can see the result value of the boundaries in the following table. Then the memberships are calculated by using some complicated methods here. For analyzing the stability of the control system, here define the performance index, and the gamma represents the disturbance suppression ability of the fuzzy system, and it's between 0 and 1. Here's some data and parameters that are involved in its analyzation. For the result, you can see the parameters of the PMSG in the following tables. And here is the experiment equipment of the PMSG system, which is located in the EPARC lab. The below figure shown that the waveform of this winding current in different generator speeds from 600 RPM to 1200 RPM. The total harmonic distortion of the waveform is listed in the below table, and the current command tracking error is less than 2.5% in all conditions. The THD is less than 2%, which means the winding currents are nearly sinusoidal as shown in the waveform. The author of this paper wants to improve the result is more reliable, so they use those parameters in the experiment to simulate by using the software PSLM version 10. You can see the simulation results. It's quite similar to the result of the experiment. This means the experiment is quite successful. In the following section, they are comparing the results of the same experiment equipment but applying different types of fuzzy control theory, which gives IT1TS fuzzy and IT2TS fuzzy control system. According to the table, we can easily see the comparison over the overshoot current and the settling time of each approach. Both of the results confirm the truth of IT2 is better than IT1TS fuzzy system. From the waveform figure, we can easily see the comparison of the current command steps in the figure A and B, which is the result with TS2, the moment that the current steps from 5 amp to 10 amps. The oscillation, or we can say the ripple, is much smaller than 1 in IT1 system. And the winding current command will go from 0 to a constant value at 1200 RPM. For the conclusions, we can see the IT2TS fuzzy control system is more complex than the IT1TS fuzzy control system. And the output power of a PMSG can be adjusted by changing the peak value of three-phase balanced winding currents. And we can expect that in the future, if the sensorless control technologies combined with the IT2TS fuzzy control system, may increase the performance of its permanent magnetic synchronous generator system. Thanks for watching.